Hello, children. I hope you are all fine and doing your studies regularly. We start with the lab preparation of hydrogen. This is very, very important for your board exam. I had asked you to draw the diagram, write down the reactants and the two equations. I will revise with that first and then we shall continue further. Reactants: granulated zinc, dilute hydrochloric acid or dilute sulfuric acid. Reaction: Zn plus 2HCl gives me ZnCl2 plus H2. This arrow upwards, what does it show? Yes, it shows that hydrogen is evolved as a gas. Zn plus H2SO4 gives me ZnSO4 plus H2. So in this diagram here, you see zinc granules down. Can you see? Dilute acid is passed from here down and the end of the thistle funnel should be dipping in the acid. This is a very, very important precaution. Otherwise, your hydrogen gas will leak out from here. And then hydrogen gas is collected here by downward displacement of water. Zinc granules. Why did I use the word zinc granules? Because it contains copper as an impurity. Copper is present as an impurity and this will act as a catalyst. So the reaction rate will speed up. A catalyst is a substance which alters the rate of a reaction without itself taking part in the reaction. So now what shall we observe? There will be effervescence. Effervescence is in the liquid, some gas bubbles are rising up. When all the air from the apparatus is expelled, you will collect the gas. Because if air is present, hydrogen forms an explosive mixture. So after all the air is removed, then only we collect the gas over water. Clear till here? I told you it is collected by downward displacement of water. Why? Because it is insoluble in water. Now, there can be another question that hydrogen is lighter than air. Why is it not collected by downward displacement of air? Because it forms an explosive mixture with air. Clear till here? So that is why it is collected over water, not air. Next is another very, very important point. The impurities which are present along with hydrogen. Hydrogen sulfide, H2S, sulfur dioxide, SO2, oxides of nitrogen, NO2, phosphine. Now this is pH3. Just like you have ammonia NH3, phosphine is pH3. Arsine, ASH3. Carbon dioxide and water vapor. So how are these impurities going to be removed? First, pass through silver nitrate solution. Silver nitrate is AgNO3. So it will remove the impurities of arsine and phosphine. So you look here. Impure hydrogen. When you pass through silver nitrate, your phosphine and arsine are removed at this stage. Further, we pass through lead nitrate solution, it will remove H2S. So there will be formation of PBS. So here is the next step. You pass through lead nitrate solution, there will be removal of H2S gas. Then we will pass through caustic potash solution. What is caustic potash solution? Solution of potassium hydroxide. So it removes sulfur dioxide, carbon dioxide and the oxides of nitrogen. So here CO2, SO2 and NO2 are removed. There must be some moisture here. So that is removed by a suitable drying agent. Here they have shown the use of anhydrous calcium chloride. Clear till here? We can also use other drying agents like caustic potash stick, phosphorus pentoxide, etc. So here we are taking calcium chloride. The gas is purified and dried and it is collected over mercury because mercury will not react with hydrogen gas. Another very important point to note, concentrated sulfuric acid is a very good drying agent, but you are not going to use it because it reacts with hydrogen gas. Still, there is lots in this part, but I will stop here. This is half of the portion of lab preparation of hydrogen. So you are going to read it thoroughly well today. Then I will tell you what to write. For your today's work, just go through it once.